Okay, your test is 3-1 through 3-4. You should have 3-5 come out right now. I'm just going to give things to you without proof. It wouldn't hurt you to do these problems because the homework will be using trig functions with the product rule and the quotient rule. So it wouldn't hurt you to do it at all. But there will be no derivatives of trig functions on the test. So you don't have to know this yet. Because we don't want to lose the day. We should push the test back because we should have the test today and tomorrow. Okay, that's what we were supposed to do, but we pushed it back so that I could be able to answer questions today. So I'm just going to quickly give you these derivatives. You fill it in. We'll come back on Tuesday, second day on the section, and talk about why they are what they are. We already know the derivative of the sine function. It's the cosine function. And the derivative of all the cofunctions are negative. Hey, Thomas, you should have this handout. You have to memorize these. And you could prove that the derivative of the tangent is secant squared of x. And we could take time to do that. It's the same thing. The question is, what's the difference between secant squared of x and secant of x quantity squared? It is the same thing. So if you want to graph this on your calculator, you're going to have a problem. This is equal to this. And your calculator does not know how to do secant squared or sine squared. It doesn't know what to do. So you have to do parentheses and then square. Now this is a cofunction. Well, let's do cotangent, because this is how I remember them. You have to memorize these, because what we're going to do is we're going to reverse them. But we'll give you lots of time to memorize them. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So that's how I remember it. I really only remember the first few, and then I remember the other ones, because I look for patterns. I don't need to go. Okay, what's the derivative of secant? It's secant tangent. And the derivative of cosecant, it's cofunction, so it's negative. Well, it's not secant, it's cosecant. See, these are the same. And it's not tangent, it's cotangent. And you can prove it using the quotient rule. But I just want to keep it simple like that. Okay. Now, so if I asked you to find, just a quick example, if I asked you to find the derivative with respect to x of the sine of x times the cosine of x, you'd have to use the what rule? Times product rule, wouldn't you? So you'd have the sine of x, here's the plan, times the derivative with respect to x of the cosine of x plus the cosine of x times the derivative with respect to x of the sine of x. And so, that's right, this is sine of x. The derivative of cosine is negative sine. And we don't simplify these, by the way. You can a little bit if you want, but don't waste your time. Plus cosine of x, and the derivative of sine is cosine of x. So this is negative sine squared of x plus cosine squared of x. And there's a trig identity, but I don't really care. Let's leave it. Don't waste your time simplifying trig. Not worth it. The only reason we ever did it was because we had to look things up in trig tables. We don't have that anymore. So there's no reason to do it. Unless you get into other techniques of doing some calculus. But you know what? Just learn it when you need to. Because you won't remember it anyway. That's all you do. So it's just a product of the quotient rule. So I'm gonna get a new smartboard here. And do I have the sparse data with answers online? I think I do. We could come back to that. But let's see what's on the test. So you have two parts to the test. You have a test tomorrow. It's Friday. That's the individual one. And you have to know concept. You have to understand concept. You have to know the definition of a derivative. So You have to do this both days. One time by yourself, one with your partner. A limit as h goes to 0, and it's f of x plus h minus f of x all over h. You should be seeing slope there. So can you find the derivative of a simple function using the limits? I think the answer is yes. For most of you, yes. That's just like that quiz. So go practice those quiz questions. Actually, those are a little harder than the first ones. Those are a little bit harder algebraically. You need to know that a derivative equals the slope of the tangent line. And there's two ways to do it. You could do f prime of x, or you could do y1 minus y2 over x1 minus x2. Right, that's going to have a specific name of a theorem that's going to be coming up. And the fly problem is the second day. Remember the sparse data worksheet? That one? It's easier than the sparse data, because remember it's a test. But the sparse data one we did yesterday, we didn't finish it. We may need to come back and look at that. It's okay, we can. So you have to be able to read off a graph. So you need to know your rules for derivatives, the shortcuts. There really isn't that much. Lots of great problems. Okay, so, what if I take the derivative of a constant times a function? Do you remember what we can do with the constant? Do you guys know why you can do that? Well, let's finish all the rules and I'll come back to that one. The constant times the derivative of f of x with respect to x. So what's the derivative of a sum or difference? Are you okay if I just shortcut it a little bit? It's just f prime plus g prime. Oh, let's make it plus or minus. So that's easy. The problem is when you get to multiplication, you think it's going to be easy like that too. But unfortunately, it's not. Remember, that's one. It's not f prime g prime. I want to make it that too, but it's wrong. F times g prime plus g times f prime. And let's get the quotient, and we're going to do this one. And so the derivative, and you have to know these. And I'm going to say 12% of you will not know these. Hopefully I'm wrong. Pardon? Sometimes, if it's a multiple choice question, and yes, the first part of the test has several multiple choice questions. They are AP questions. They are actually in your possession. If you go to Blackboard and you look at the multiple choice questions, you have them. There, it's under the AP exam stuff. All the solutions are worked out. So you could, if you can recognize what it is, you could actually do them beforehand. Okay, so what's the quotient rule? So you start on the bottom and you go up. Minus f g prime over g squared. But I'm trying to think of what else there is. I'm going to do that, but I don't think there's much else in there, but you have to be able to apply it. Oh, 3 point, oh yeah, we see the positions. That's right. Yes, there is that on there. Okay, let's do this, and then I'll add a page, and then we'll go through reviewing the position acceleration stuff. Okay. And I think this partner test is a little bit harder. Let's do the proving of this constant one. Let's do this one. Because what rule is this? It's the what rule? K times f of x. You're not adding them. What are you doing? K at f of x. What are you doing? Adding, multiplying, dividing? You're multiplying. So I have to use the multiplication rule. So let's do that. So it's the derivative with respect to x of some constant times f of x. Using the product rule, then it's the constant times the derivative of the first, or second one, so do it the other way around, plus the second one times the derivative with respect to x of a constant. Well, this is k. This is the derivative of f of x with respect to x, plus f of x. But what's the slope of a horizontal constant line? It's 0. That's why that works. That's why you can pull the k through the operator. Because this term, these are terms, it's 0. So you could always work it out. It's kind of wasting your time. It's better to just know it. Okay, so now we have, that was 3.1 and 3.2 is the definition of derivative. 3.3 were the rules, the shortcuts, and 3.4, which is not a particularly great section, but it's about the position stuff. And we would give you, if it's a falling body, we would give you the equation. But if S is equal to your position, then how do you find your velocity? So it's the change in S divided by the change in time. Now this is instantaneous. I hate that word. And what about, okay, let's do speed while we're here. Speed is the absolute value of that. Okay. And what about, well, back up. What about average velocity? The average. Remember, when we have your curve, if this is your position curve, if you join these 2 points here, T1 and T2, this is the slope. No, average is the slope of the secant. I'll write it. Remember, just think in the real world, because most of you drive, it's the slope of the secant line. What are you averaging for your speed? When you travel 55 miles per hour, that's an average. You say, well, okay, I drove to Duluth and I traveled at 55 miles per hour. You didn't travel 55 miles per hour the entire way. You had to be 0 at some time. You had to be going slow to merge into traffic and stuff. So this is S of T2. So it's easy. It's just slope. Your average rate of change is just slope. T1. So this is the average rate of change. You can't shortcut the words. Can't you? What was that? Oh, okay, no big deal. Average rate of change. This is the instantaneous rate of change. I hate that word. So that's what you see on your speedometer. You see the derivative there. Well, and then if I want to draw that, whoops, that's the tangent line. There it is. Someplace that they are going to be the same, but not always. So you got to get the difference here. Average rate of change is just plain old slope. That's all it is. Old-fashioned slope. And at some place in time, your average and your instantaneous will be equal. And you don't have to know this yet. That's called the mean value theorem. That's correct. It's the derivative. Let's label that too. It's the derivative. So if you think about it, if my curve looks like this, and I find the slope of the secant line, don't you think someplace in here there'll be one that's the same slope? Yeah, it's called the mean value theorem. Don't have to know that, not yet, but you will have to know it well. It's all saying that they're equal, so it's really not even hard. So I actually just did the mean value theorem. Okay, what else do we have to know? Oh, acceleration. Okay, keeping going. The acceleration, that's the instantaneous acceleration, not the average. Which brings up a great question. That's going to be the change in the velocity with respect to time. What would the average acceleration be then? Yeah, acceleration average is going to be the change in the velocity divided by the change in the time. It's the slope of the secant. It's just plain old slope. You got to think. Well, it's too much memorizing otherwise. So to find your average acceleration, you would find the velocity at T2 minus the velocity at T1 over T2 minus T1. The derivative is at an instant. 1 point. Make sense? Okay. You might. You will need a calculator for one problem. You're only allowed it on one problem. You can borrow my calculators if you don't have one. But you will need a calculator. Because if it's a calculator question, you want to use it. Okay. And maybe we need to talk about, remember how to find the derivative at a point on your calculator? You have to go into math, unless you have the new operating system. 8, I think it's 8, and derive. You put your function in here, it's f of x, comma, a. That's how you find a derivative. You do have to prepare for doing it using a calculator on the exam. So yes, you have to be able to do that. Pardon? It's a little easier. You can use the shortcut keys, the top ones on the top. It's still n derive. It's still n derive. But it will look like, on the new one, it'll look like d, something like. So what you'll do is you'll put in your function here, maybe it's in y1, always with respect to x at this stage, and then maybe it's at some point a. You just have to arrow over with your little arrow keys. So it's so easy because it looks like what you want, right? Okay, it might be slightly different. Maybe the y1's over here someplace. Is that over here? Okay. But whatever, it's the same thing. Okay, one last thing about this. With the motion problems, and we can do some problems out of 3-4 if you want, you need to know when the particle is speeding up or slowing down. Do you remember that? Speeding up when A and V are the same signs. And it's slowing down when they're opposite sides. Do we have a homework problem like that? A and V are opposite sides. And if you think for a moment, what's hard? You're speeding up or you're slowing down. What has to be true to be stopped? No signs meaning what's true about the velocity. The velocity is 0. So you're stopped when the velocity is 0. You guys know that though. Doesn't that make sense? Now, have I missed anything? So how would I study for a test? Be able to do the problems. What does it mean to be differentiable? A little more vocab. Continuity. What does continuity mean? We have not gone away from continuity or limits. All of that is still fair game. What has to be true for a function to be continuous? The value of the function has to exist. You can't forget this because it gives me a math equation actually. And what else is going to be true? The limit. Now, how do you know that the limit exists? It has to approach the same value from both sides. Do we care about f of c? No. So the limit from the left has to equal the limit from the right. And if you truly understand this, you should be able to apply it very easily. I think some of the questions are easy if you understand this. I'm going to write, we don't care about C. Not for this part. I do care about C for continuity or a limit. I'll be very particular about that. So for a limit to exist, I don't care about C itself. But if I want it to be continuous, see, that limit exists here at C. That's not a problem. Because what is a limit? It's the y coordinate. Well, y is getting close to something. I can get really close to C. Y is getting really close to something. I don't know why, but we'll call it L. But it's not continuous because this has to be the same. Let's see if I can do that. Oh, there. It's got to be right there. Remember that? Can't forget it. So this is an equation. The limit as x approaches c of f of x has to equal f of c. And when you have that, you have information that you can write a math equation, solve. You can actually do it. So you can find some things. You've had some problems like that. The other thing to do would be to go back and look at any of those handouts we gave you. Any of those things. We give those to you to prepare you. It's not just to fill time. We have too much stuff to do as it is. Now, one other word here that goes with continuity, it's stronger than continuity, is differentiability. We have to know that word. Differentiable means you can find the derivative. And Evelyn says, if it's differentiable, then I'm going to even write that way she wrote it, the way she said it. Differentiable implies continuity. So when they tell you that your function is differentiable, then you know it's continuous. And for differentiable means that the derivative f prime to the left of c has to equal f prime to the right of c. You can't have an abrupt rate of change. You can't have an abrupt slope change. It's got to transition nicely. Okay? To the right of c. So if you have a function like this slope is positive 1, this is negative 1, they're not transitioning nicely. You're going to go positive 1, you're going to go forward, and all of a sudden you're going to shift your car into reverse without stopping and go backwards. It's going to clobber your car, right? So that, to be differentiable, it's got to be nice. It's got to be smooth. Oh yeah, then your gears grind, because you know what, I've done it. Okay? It's got to, here's your slope of your tangent line. See how it's gradually changing? It's not an abrupt change. Sorry, I'm a little off. So there's no abrupt changes in the derivative. So when you know it's differentiable, you know that the two derivatives on each side have to be equal. Do I need to say that again, Sam? If it's differentiable, the derivative on both sides of my c value have to be the same thing. So if I gave you that for x is greater than 0, f of x is equal to x squared minus 3x, and x is less than 0, f of x is equal to 2x minus 3. I don't want to do that. Never mind. I want to say it's is equal to x plus 1. Is it differentiable at 0? You've got to do the derivative on both sides. So for this side, what's f prime? It's equal to 2x minus 3. And what's this one? It's 1. Now you get to evaluate it at 0. So at 0, this is negative 3. This one is at 1. Not differentiable. I meant to find one that was, but that's okay. For it to be differentiable, it's got to be the same coming in from both sides. Is it continuous at 0? How do you know? If it's continuous, then you have to be able to find f of 0 and the limit as x approaches 0. Actually, it's a good example of f of x. What's f of 0? The little piecewise functions. Lots of piecewise functions on the exam. F of 0 uses this formula right here. So f of 0 is 0 squared minus 3 times 0 plus 1. What is it on the right side? It's 0 plus 1. So yeah, it is continuous, isn't it? Can you tell me, do you have an idea what's happening at 0? You're going to have a sharp corner because you have a parabola. I don't know what it looks like, but it's a sharp corner. It's probably going to go like that. So where are functions not differentiable? Not differentiable at sharp corners, you told me. It's also called a cusp. I don't care. Anytime there's an abrupt change, good enough for me. The vertical tangent one is the one I always forget. Vertical tangent, and it shouldn't be because the tangent line's a vertical line, and we know the slope doesn't exist on a vertical line, right? And any discontinuity. That's the easy one that we tend to forget. So if I'm going to see if it's differentiable, first I'll see if it's continuous. Because if it's not continuous, I'm done. Then I don't have to do a derivative. So do you see how I use both concepts together here? Do I need to review that again? Okay. You've got it in the video, so you can go back and see it again. So when you have a derivative, if it's differentiable, you know it's continuous, and the derivatives have to be equal from both sides. We can, oh, that was the last thing we have to know. The tangent line is a vertical line. So, I mean, I could graph it on my graphic calculator. So you have y is equal to the cube root of x. Let's see why it's a vertical tangent. We haven't done this. We may, no, well, we did. We looked at it, but let's do it. The problem is that x equals 0 because the graph looks like this. So if I were to draw the tangent line here, that slope is undefined, right? We know that because it's a vertical line. That's what a vertical tangent is. But why is it vertical? Because what's true about the derivative? Let's find the derivative at 0. What's y prime? Power rule, 1/3 x subtract 1. 1/3 subtract 1 is negative 2/3. I don't like fractional exponents. I don't like negative exponents. So I will rewrite it. So it's 1/3. Now, what is that negative 2/3? That means it's going to go in the denominator. It will be the cube root of x squared. What happens when x is 0? No, it's not negative. It's because it's going to be 1/0, just undefined. Tangent. Does f of 0 exist? What is f of 0? If it was not there, I would say it's a vertical asymptote. But it's the cube root of 0, which is 0. It does exist. If you zoom in on it, you can't draw. You can't see that part because you keep zooming in. Now it's vertical. The calculator doesn't know what to do. And the last thing you have to be able to do is, given a function, any function, find its derivative. Remember we had a bunch of graphs that you were supposed to match. You were supposed to draw the derivatives. That type of problem. So it's not hard. It's not meant to be hard. No, it's what you actually will collect data on will never be the function. It will be the derivative. Where are the most important places on my graph? Here's f of x. The zeros. Now I want to look for f prime. So here it's 0. So there it is. Here it's 0. Are we okay with the zeros? What's true about the slopes on this side? They're positive. So these numbers are going to be up here. And now what happens to these little slopes? They're negative. You're right, they're decreasing as well. Are they decreasing? Well, they're decreasing here, and then they're increasing again. So it's negative. And then what's true about the slopes here? They're positive. So that would be f prime. That would be a quick sketch of it. The big thing I look for are the zeros, and just positive, negatives. That's all I care about. Kevin.
As horizontal lines, and you have to put the little dots in.
No, you're different question. I know what you're saying. So if I have y equals the absolute value of x. So if I want to look at that one, here's the function. Now what's true at 0? The slope doesn't exist because is it 1 or is it negative 1? So here it's negative 1, here it's 1. So it's this function. But I don't know what to do with 0, so it's open. And here it's 1. There's the derivative. Yes. Can't include it. It's not differentiable. Sharp corner. I think, but I'm swear to it. Then I got everything. The book is kind of hard to read, but there are key things here. Intermediate value theorem is important to know, but we're not going to test you on it yet. always been on the exam. Every topic that we cover in this class is tested on the exam somewhere, either multiple choice or free response. Every single one. And I know that because I went to the chief grader and I said to him, I don't think this topic was covered. And he goes, every single topic is covered. I said, I know, but the kid said it wasn't there. And he goes, you're not supposed to talk to the kids about what's in the exam. Okay. Yeah. No, it's not good. Higher order derivatives, first and second derivative. Yes, I got scolded. Well, you guys, I mean, they told me. What could I say? I don't know if there's anything that you want to look at out of 3-4. Now, 3-4 will be collected on Monday. Now, also for Monday, I got a couple announcements. Section 3-4 will be collected Monday. Hersman's doing the same thing. And we are not going to have extra help Monday morning because we have to have a PLC meeting. So no extra help Monday morning. Now, Monday's your partner test. And again, they are AP problems. Now, these are free response problems. You still have to know the same content. You have to know the concepts. You have to know about velocity. I think you'll be okay. Now, does velocity have direction? Yes. So let's go back to, where's my velocity one? I want to go back and look at that. That's this one. So, when your velocity is, since it has direction, I'll put it in the bottom here. If the velocity is positive, you're moving to the right or you're moving up, depending which way your coordinate system is. If your velocity is negative, you're moving to the left or you're moving back down. So, this is your right. It would look like this. I'm going to the right, my velocity is positive. Now I'm going to go back, my velocity is negative. So if you looked at a velocity graph, so if you had a velocity like this is V, this means you're going to the right, there's 0, you stop, and this means you're going to the left. The velocity is negative. I could do it parametrically. You can if you do it only in one-dimensional picture. So if you have S equals t squared, make it something simple. What's your velocity? 2t. Oh yeah, we can talk about what happened. Usually they'll say t is greater than 0. So if I wanted to do a schematic for this one, schematic is where you're actually going to plot where you are. So when t is equal to 0, here's your position graph. When t equals 0, you are at 0. What at 1 second? Then I can do this if you want me to bring the calculator up. I can do it parametrically because it's really cool to see. What happens at 1 second? You're going to be over to what? Your position will be 1. What about t is equal to 2? Where are you going to be now? T equals 2, what's your position?
2.
No, it's squared. 4. Right? What happens at 0? What happens to t equal to negative 1? What's your position? S is equal to 1. So it's going to be here. I can't, seriously, it's all on this one line. You can't see it. I can do it on my calculator, but it was just kind of cool to see. But it's going to come here. So in the past, it was doing this. Because what's about the velocity at negative 1? What's v of negative 1? It's negative 2. So it's moving to the left, and then it's going to stop, turn around, and come over here. I got 6 minutes. Let's show that graph. Because it's kind of cool. We aren't going to test you on this one with my calculator. Not on the schematics. Now I'm going to change my mode. So remember all this stuff? And you can just watch. I'm going to change this to parametric. Because I really wanted to see it that way. So I'm going to do y equals clear. And I'm going to let my x value be t. And this is going to be t squared. Oh, no, I don't want this. Make this 1. And I'll make this This is my position, t squared. Want y1 and x to be t squared. There we go. There you go. There's your position. Your x position is t squared. Okay, so we're going to zoom it. Okay, guys? Let's do our window from negative 4 to 4. Whoops. Oh, wrong sign. And we'll make this a 4. We'll do a t-step of 0.1. You don't have to worry about this, but it's going to calculate every 1/10. And let's see, the x's, now 4 squared is going to be negative 16. But it's never going to be negative, is it? So let's make the x min be negative 1, and then we'll go to 20 on this one. And the y's, I'll just count by ones. We'll start at negative 1, and we'll go up to 2. Now, watch this. Watch it quickly. It's going to give it to you in time. There it comes. What's it doing? It's slowing down, and it's what? Stopping. And then it's speeding up. So the problem is, now you get a line there. So you see absolutely nothing. But if I trace on it, I can get my position, and look at that. It gives me my position here, and it tells me what the time is. Okay. There we go. Remember, where does it start? At t equals negative 4, where are you? It's x equals t squared. 16. So that's where we're going to start. There it starts at 16. And now look at it slow down. Stops. Let's do it. Okay, so we're going to make, what's the velocity? It was 2t, right? And we'll, let's just leave it at 0. It doesn't matter. I just have to place it someplace. We'll see what happens here. Whoops. Okay. Now I can do it simultaneously. Oh, and now I can see the negatives, so I don't need negatives. Now, my problem with my window is it's not big enough. So first off, I want my x's to be negative. So we'll do negative 20, and it's 2t, and I got to make my y's go from negative 5, maybe. Let's do negative 10. 10. And I'm going to do one other thing, because I haven't seen this. We'll do it simultaneously. So you're going to see your velocity. Now you got to watch quickly. Simultaneously. Okay, there's your position. Now where's my velocity? Oh, I think I know what's wrong. Let's make that t. Okay, there's your velocity. Velocity here, your velocity is negative now. Because you're going left. It's going to stop. And then what? It's going to go back to the right, so the velocity is positive. So I can actually take a problem with a cougar chasing a fawn and see if you can actually see the motion and see if it catches it. It's parametrics. We're not doing parametrics. But if you want to do it, all the stuff's right here on the video. Okay. Here tomorrow morning? Not Monday morning. Question? Yes, it'll be posted up on Blackboard.